that equal to 2m. The value of L1, L2 and M are respectively. The value of L1, L2 and M are respectively dash. Yes. Yes, friends. It is connected in which case? Parallel. To achieve the maximum possible equivalent inductance. In parallel connection, to get the maximum possible inductance, we can prefer the parallel aiding or parallel opposing. We can connect in parallel aiding or parallel opposing. Yes, friends. To get a maximum inductance in parallel connection, yes, parallel aiding is used. Parallel aiding connection is preferable. Yes. Then in parallel aiding connection, what is the L equivalent? What is the L equivalent? What is the L equivalent, students? The L equivalent equal to L1 L2 minus M square by L1 plus L2 minus 2M. It is not plus 2M, it is a minus 2M. Yes. Now we want to find the L1 and L2 and M. Okay. But what the L equivalent is given? Given that L equivalent equal to 7 Henry. This is equal to 7 Henry. Okay. Now I want to substitute this total formula in terms of L1 or in terms of L2. For example, I am doing in terms of L1. L1 equal to half L2. Then what is L2 equal to? 2L1. 2M equal to L1 from this one. 2M equal to L1. What is M equal to half L1? That I am substituting here. L1 into what is L2? 2L1. What is M? Half L1 whole square by, yes friends, this I am doing L1 plus L2 is 2L1 minus 2 into M is half L1. Yes, from this we can calculate what is it is equal to 7. It is equal to 7. Then you can solve for L1, students. Then how much L1 we can get? We can get L1 equal to 7 Henry. By solving this, we can get L1 equal to 7 Henry. If L1 equal to 7, then what is L2? L2 equal to 2L1. That is 14 Henry. Then what is M? M equal to half L1. That is 3.5 Henry. That is 7, 14, 3.5. 7, 14, is it correct? It's sorry. M equal to half L1. L1 how much you got? 8 Henry. L2 is how much? L1 is how much, friends? It's not 7 Henry, sorry, it is 8 Henry. Please do that. It is 8 Henry. If L1 is 8 Henry, then you substitute here. How much L2 you got? 16 Henry. If L1 is 8 Henry, then what is M? M is 4 Henry. M is 4 Henry. Okay. Then what is our answer? 8, 16, 4. 8, 16, 4. Then which option is correct? Option A is correct. Clear, friends? It's very simple. This is the L equivalent. Why you are used, sir? Only aiding connection. Because maximum possible equivalent inductance. Now, I am writing this equation total in terms of L1. But L equivalent already given, 7 Henry. That I am equating to 7. I am getting L1 equal to 8. Once I know the L1, What is L2? L2 equal to 2L1. From these two equations, L2 equal to 2L1. That I substituted 2 into L1, 2 into 8, 16 Henry. What is M equal to half L1? Half into L1 is how much? 8. 8 by 2. 8 by 2 is means 4 Henry. Then 8 Henry, 16 Henry and 4 Henry. Clear? Understood, students? Next. For the circuit shown below, the equivalent inductance is dash. Come on, do this. In this circuit, what is the equivalent inductance? Yeah. L equivalent equal to, yes, friends. First, add all the self inductance. 4, 5, 6. 4 plus 5 plus 6. Then check the mutual inductances. First, I am checking for 1 Henry. This 1 Henry is between this coil and this coil. For this coil, it is a starting terminal. For this coil, it is an ending terminal. Understand? That's why adding or opposing. Opposing means minus 2M. Minus 2 into 1. Next, I'm checking for 2 Henry. 2 Henry is defined between these two coils. For this coil, it is ending terminal. For this coil also, it is ending terminal. Dots are issued at ending terminal. Both are ending terminal means adding plus 2M. Next, I'm checking for 3 Henry. 3 Henry is defined between these two coils. For this coil, it is a starting terminal. For this coil, it is an ending terminal. It is opposing. Minus 2 into 3. Now tell the students. 4 plus 5, 9. 9 plus 6, 15. 15 minus 2 plus 4 minus 6. That is, this is how much, friends? 19 minus 8. 19 minus 8 is 11 Henry. Which option is correct? Option A is correct. Clear? Any doubt? Respond. Yes. Okay. Like this we can solve. Yes, friends. This one more question. A linear transformer and its equivalent circuit as shown in figure A and B respectively. What are the values of L1, L2 and L3? That is not L1, L2 and L3. Yes, this is the symbols. What are the values of L1, L2 and L3? This is L1. This is L2 and this is the L3. Yes, friends. Then we are converting this into pi network. This is pi. In the yesterday class, I explained about this one, formulas. Once we can convert this coupled circuit into pi network. In an equivalent pi network, I'm explaining solution. In an equivalent pi network, then what is L1, students? This formula is already given. L1 equal to L1 L2 minus M square by L2 minus M. L2 minus M. L1 equal to N1 L2 minus M square by L2 minus M. What is L1? 8. What is L2? 5. M square means 2 square by L2 is 5. M is 2. Then how much we can get, students? 40 minus 4, 36. 36 by 3. 36 by 3. This is how much? 12 Henry. What is L2? This L2 equal to L1 L2 minus M square by this is L1 minus M. In equivalent pi network, students. That is 8 into 5 minus 2 square by L1 is 8. 8 minus 2. That is 36 by 6. That is how much? 6 Henry. Then what is L3? I'm writing formula for L3. All these formulas are already given in the previous session. That is L1 L2 minus M square by M. That is 8 into 5 minus 2 square by 2. That is how much? 40 minus 4, 36 by 2. That is 36 by 2 is how much? 1800. Then what is your answer? 12, 6, 18. 12, 6, 18. Then which option is correct, friends? 12, 6, 18. Which option is correct? Option B is correct. Yeah, this is the equivalent pi network. How to convert the coupled circuit into pi network? I already given the formulas for T network also. But here it is a mutually aiding connection. That it is a M is positive or negative, you take that you have the doubt, because it's a aiding connection. For this coil, dot is issued at starting terminal. For this coil also, dot is issued at starting terminal. That's why you can take the M is +2. For example, if it is the dot and here it is the dot, then you take the M is -2. Take the M is -2. Clear? Based on the it is a aiding or opposing, that you can consider the M. It is a because dot is issued at starting, here also dot is issued at starting. That's why you can take the M is positive. Clear, students? Okay, like this we can answer how to convert this coupled circuit into pi network. Yes. One more question. All of you try to answer this question also. Come on, do this. Any response? Try this, students. Yes. Any answer? Naga Soumya, sir, one slide to previous. Third problem. Sorry, I'm not seeing your comment. It's a third problem. Yes, check it. Yes. Now, okay. All of you understood this one, students? All this? Can anybody answer this question? Answer for this? Yes, I'm explaining. It's very simple. For the solution for this problem, here itself I'm explaining. The equivalent inductance of a pair of coupled inductors in various configurations. 7 Henry after series aiding connection. Series aiding means, what is the L equivalent? L1 plus L2 plus 2M. This is how much? 7 Henry. 1.8 Henry after series opposing connection. L1 plus L2. In this case, what is the equivalent inductance? Minus 2M. Is how much? 1.8. 0.5 Henry after parallel connection with dotted terminals connected together. 0.5 Henry with dotted terminals connected together. Dotted terminals together means like this. Both are dots here, or both the dots are here. Dotted terminals together. Dotted terminals, that is aiding connection. That is also aiding connection. But it's a parallel connection, it is aiding connection. Then in this case, what is L equivalent? L1 L2 minus M square by L1 plus L2 minus 2M. Minus 2M. Because it's aiding connection. Dotted terminals connected together means it is starting, it is also, or it is also start ending or ending. Both the dots are at ending terminal, or both the dots at starting. It is a aiding connection. Okay. This is how much? 0.5. Then you want to find L1, L2 and M. First, this equation 1, this is equation 2, this is equation 3. By solving 1 and 2. By solving 1 and 2 students. By solving 1 and 2. Then what I can do? I will do the 1 plus 2. Nothing is there here. 1 plus 2. When I do the 1 plus 2, 2m is cancelled. When I do the 1 plus 2 students, that is 1 plus 2 I am doing. Then L1 plus L2 plus 2m plus L1 plus L2 minus 2m is equal to how much? This is 7 plus 1.8. That I am getting 8.8. Plus 2m minus 2m is cancelled. 2 into L1 plus L2. That is 8.8. Then what is L1 plus L2? Is equal to 4.4. L1 plus L2 equal to 4.4. Then what is the from third equation? From equation 3. L1 L2 minus m square by L1 plus L2 minus 2m is equal to 0.5. Then L1 L2 minus m square by, yes friends, L1 L2 minus m square by, before that, if L1 plus L2 equal to 4.4, if L1 plus L2 equal to 4.4, take either equation 1 or equation 2. Take any one equation. Then from equation 1, what is the L1 plus L2 plus 2m? Is equal to L1 plus L2 plus 2m is how much students? It is equal to 7. Is equal to 7. Then from this, what is the 2m equal to? 7 minus 4.4. 7 minus 4.4 is how much? Come on. 7 minus 4.4, 2.6. Then what is m? 1.3 Henry. Now you substitute here. L1 plus L2 is how much? 4.4. M is how much? 1.3. That I am substituting here. This 1.3. This L1 plus L2 is 4.4. 4.4 minus 2 into m is 1.3 is equal to 0.5. Then from this you can calculate L1 into L2. How much L1 into L2 you can get, students? 2.59 Henry you can get. Yes, once you know the L1 into L2, then I'm writing L1 minus L2 whole square. A minus B whole square equal to A plus B whole square. A plus B whole square. That is L1 plus L2 whole square minus 4AB. A minus B whole square equal to A plus B whole square minus 4AB. Minus 4 into L1 into L2. Yes. L1 plus L2 is how much, students? 4.4 square. Minus 4 into, what is L1 into L2? This L1 into L2 is how much you got? 2.59. Then you can solve for L1 minus L2. Then from this you can solve for L1 minus L2. What is this L1 minus L2 you can get? Can anybody answer? I think you can get L1 minus L2 3, no? 3. This L1 minus L2 is 3. What is L1 plus L2? L1 plus L2 equal to 4.4. By solving these two, important for 2 marks, these two equations, then what is L1 we can get? We can get the L1 is how much, students? 3.7 Henry. What is the L2 we can get? L2 equal to 0.7 Henry. Already M is calculated. M is 1.3, L1 is 3.7, L2 is 0.7. Then what is your answer? L1 is, what is the L1, sir? How much? L1 is 3.7, L2 is 0.7. L1 is 3.7, L2 is 0.7, M is 1.3 Henry. Option C is correct. Yes, friends, all of you got this? This is the solution. But somewhat lengthy, but this is the procedure. Once you know the formulas in a coupled circuits, solving of the problems is very easy. In detail about these formulas, I already discussed in the previous sessions. Who are not attended that sessions, please once again, you please go through that. Yeah, this is the calculation of L1, L2, and M is already calculated. That is M equal to 1.3 Henry. Yes. It's a very simple question. You can answer in fraction of minute. I'm expecting answer from you. What is your answer, students? Come on, do this. I'm expecting answer from you. Everybody, respond. Any answer? Two zero four 2A6 256. The question is not visible. Yes, this is the question. What is the value of L equivalent in the circuit shown in figure? Yes, it is a parallel, aiding or opposing. Is it a parallel, aiding or opposing?
Opposing.
Very good. It's a parallel, aiding. It is opposing. What is your answer?
5, sir.
So 5 Henry.
Yes.
Once again, check that. And opposing means L equivalent equal to L1 into L2 minus M square. It is as it is. But here denominator it is changing. L1 plus L2. You don't. It is opposing. It's not minus 2M. It is a plus 2M. In aiding we can get minus 2M, but in opposing we can get plus 2M. You please check this one. Then what is L1? 5. What is L2? 10. What is M? 5 square. What is L1? 5. What is L2? 10. What is M? 5. That is 50 minus 25 by this is 25. It is a 25 by 25. Is it correct? This 1 Henry. Got? This L equivalent equal to 1 Henry, students. It is not minus 2M. It is a plus 2M. Yeah. Maybe you substituted minus 2M. That's why you got 5. That is wrong. Okay. This is for opposing. If it is aiding means here it is a minus in parallel connection. Next. The equivalent inductance seen from terminal AB in the following network is. What is the equivalent inductance seen from terminal AB in the following network? Yes, come on, do this.
20 option D, sir.
Option D. We are getting 20 Henry. Yes. We'll check that. Actually, here the secondary terminals is shorted. But here it is not given that it is aiding or opposing, because we don't know about this dot polarity. Dot polarity is not given. Yes. Then how you are calculated for this one? See, first you convert this into star equivalent. Let assume that unless otherwise specified, if you take the aiding, let aiding connection. Okay, assume that it is aiding. That it is aiding connection, because dots are not given. Then if you convert into star T network, sorry, it is a T network. What the T network? This is the T network. This is L1 minus M, L2 minus M, and this is the M. But these terminals are shorted. Is it correct? The terminals are shorted. Then shall I write like this? This is L1 minus M. L1 minus M means 10 minus 4. 10 minus 4, 6. This is M. This is 4. And this is L2 minus M. Yeah. L2 minus M. I'm getting negative sign. Inductance is negative means it is a meaningless. That's why you take opposing. When I take the L2 minus M, I'm getting the, which one, students? 2 minus 4. How much I am getting? Minus 2. Minus 2 means inductance, negative means that is me. It is not a reactance, it is inductance. Okay. Reactance may be positive or negative, but always the physical values must be positive. That's why L2 minus M, I'm getting 2 minus 4 minus 2. That's why it is wrong. That's why let consider aiding is not possible. Then consider opposing. Consider the opposing. If it is opposing means L1 minus M, this is L2 minus L2 minus of minus plus, we can get. Yes. But this mutual inductance is minus M. Based on the polarity, dot polarity only, it is a minus M. Then you take the magnitude. I don't know about the polarity, or otherwise you can do like this, because polarity is not given. I don't know, is it aiding or opposing? Then I will go for one more method. Better to go for this method. I will do the next method. See this one. Just a minute. See, let the input voltage is Vin. Let assume that the input voltage is Vin, students. Then how to write Vin equal to? This Vin equal to, come on, Vn equal to, let the current in this is I1, and here the current is I2, because it is shorted. It is a shorted. That's why there is a current. Shall I write like this? L1 into di1 by dt, L1 into di1 by dt, plus or minus, I don't know polarity, that's why plus or minus m into di2 by dt. Yes. Now we'll see for second in this loop. Here I'm applying KVL. This is Vn. For this this is for first loop. In the secondary side that I am writing, L2 into di2 by dt plus or minus m into di1 by dt. di1 by dt. But it is shorted now. That is equal to 0. M into di1 by dt. Okay. Now see. L2 into di2 by dt plus or minus M into this mutual inductance with respect to this coil plus or minus M into di1 by dt. Then from this, what is the di2 by dt? This di2 by dt equal to di2 by dt equal to what you can write? If you go this side, minus half plus M by L2 into di1 by dt. Then what is Vn? Vn equal to L1 into di1 by dt plus or minus M into, but I am substituting di2 by dt. What is the di by dt? This is M by L2. M by L2. Is it correct? M by L2 that I have written here. M by L2. This L2 I am bringing this side. Then plus or minus M into minus plus M by L2 into di1 by dt. So I am substituting di2 by dt here. Okay. Then into di1 by dt. This plus minus, it is a minus plus. This is the plus minus, it is a minus plus. Then what you can get here? Vn equal to L1 minus plus into minus, minus, minus into plus is also minus. L1 minus M square by L2. M square by L2 into di1 by dt. Is it okay? Now I got this resultant input voltage. This indicates L equivalent. Then what is L equivalent? L1 minus M square by L2. L1 minus M square by L2. Is it correct, students? L equivalent equal to L1 minus M square by L2. Then this is the L equivalent if one of the side is short circuited. So directly don't take it is a parallel connection. Don't take directly it is a parallel connection. This is the transformer, sir. This is the transformer. Secondary is shorted. Secondary is shorted. Okay. There is no electrical connection there. L1 minus L2 by, sorry, M square by L2. M square by L2. M square by L2. Is it okay? L1 minus M square by L2. What is L1? It is given. How much L1 it is given? 10. This is the 10 minus M square. M square is 4 square. 4 square by L2. L2 is how much, students? L2 equal to 2. This is equal to 2. That is 10 minus 16 by 2. That is 10 minus 8. That equal to how many Henry we are getting? That is equal to 2 Henry. Very good. That is the correct answer. Then how much we are getting? This is the 2 Henry. It's not 20. It is a 2 Henry. Is it clear, sir? Understand? Like this, we can write the equations. Or you can also try by using the T network. If you try by using the T network, assume that it is aiding connection. Method 2 I am explaining. Let aiding connection. Aiding connection. If you write in terms of T network, this is L2 minus M. This is M. This is L1 minus M. This is L equivalent. These two are parallel. These two are parallel. Then what is L equivalent equal to? L1 minus M plus L2 minus M in parallel with M. Shall I write like this? L1 minus M into L2 minus M into M by L2 plus L2 minus M plus M. Parallel connection. Then MM cancel. Then what you can get? L1 minus M. Multiply this one. Students, plus L2 M by L2 minus M square by L2. M square by L2. This L2 cancel, plus M minus M cancel. L1 minus M, same formula I'm getting. L1 minus M square by L2. Are you getting same formula or not? Unless otherwise specified, you take the aiding, sir. Then according to that, you follow aiding connection. L1 is how much it is given? L1 is 10. 10 minus M is how much it is given? 4. 4 square by 2. 4 square by 2. Are you getting same answer or not? 2 Henry. Like this. You can go for this method too, or if you want to write the equations, then according to that equations also you can write. Like this you can proceed. Okay, students? Yeah, this is the method 1 and method 2. Clear? Any doubt? Unless otherwise specified, you can take the aiding connection. If it is opposing, means this is plus, this is plus, this is minus. You try for opposing also, but that answer will not appear in the given options. They will give any one answer only. Either aiding answer they will give or opposing answer they will give. Clear? Yes, friends. Next. In the following network, if I1 of t equal to 4 cos 100t ampere, then what is the value of maximum energy stored in the network? You want to find the maximum energy stored in the network. Yes, just now I given the formula. What is the total energy? The total energy equal to, yes, half L1 into I1 square plus half L2 into I2 square plus or minus M into I1 into I2 plus or minus M into I1 into I2. But here 3 inductances are given. Here it is given that 3 inductances. Then we can also write half L3 into I3 square. One more inductance also given. Plus half L3 into I3 square. Plus or minus M into I1 into I2. Yes, but here all the only one current is given because it's a series connection. The current remains equal current here. Then for maximum energy, what is current is given? The current equal to 4 cos 100t. For maximum energy, to get the maximum energy, you want to substitute the maximum current at t equal to 0. At t equal to 0. Then what is I equal to 4 amperes. Now half into L1 is how much? 4 Henry. I1 square, that is the 4 square. Half into L2 is how much? 5 Henry. I2 square, the current remains same, 4 square. Half into L3 is how much? 6 Henry into 4 square plus, but aiding or opposing, you can take plus or minus. With respect to this 3 Henry is defined between these two coils. For this coil, starting terminal. For this coil is also starting. That's why you can take plus M. Plus 3 into I1 into I2. I1 is also 4, I2 is also 4. I1 into I2. I1 is 4, I2 is also 4. Same currents. I1, I2, I3. Here I1 equal to I2 equal to I3 equal to I only. Okay, students. Then how much energy we are getting? Respond. What is your answer? Half into 4 square plus half into 5 into 4 square, half into 6 into 4 square plus 3 into 4 into 4. What is your answer, students? Respond. I'm doing the calculation. 64 by 2, 32. This is 80 by 2 plus 40. This is how much? 96, 2 plus 48, 4,
168, sir. C option.
168 joules. Very good. That is correct. Option C is correct. Because here are 3 coils are given, that's why you take half L3 into I3 square. If 4 coils are given, half L4 into I4 square. Like that you can consider. This is the total energy stored. Important model already framed in all the compute exam, this model. So what is the voltage V0 in the circuit shown below? Let's try this one. You want to find the what is the V0 in the circuit shown figure. Okay, you can try this one for assignment. If any doubts, you can ask me. And all these questions I am giving assignment for you. This also try for assignment. If any doubts, you can ask me. Try by your own. Two coils connected in series have an equivalent inductance of 6 Henry when connected in aiding and an equivalent inductance of 2 Henry when connected in opposing. The value of mutual inductance between the two coils is. Come on, fraction of minute you can answer. Respond. Respond. Yes, students. Two coils connected in series have equivalent inductance of 6 Henry when connected in aiding. Then 6 equal to L1 plus L2 plus 2M. When connected in opposing, 2 equal to L1 plus L2 minus 2M. Then you want to find the what is the mutual inductance. How much you got? Let this is the 1, this is the 2. Add 1 plus 2. If you do the 1 plus 2, what you can get? 2 into L1 plus L2 is equal to 8. What is L1 plus L2? How much L1 plus L2 you got? 4. This L1 plus L2 equal to 4, sir. If L1 plus L2 equal to 4, take either equation 1 or equation 2. From equation 1, L1 plus L2 is 4. 4 plus 2M equal to 6. 4 plus 2M equal to 6. Then from this, what is the 2M equal to 2? What is M? How much you got? 1 Henry. Simple question. M equal to 1 Henry. This is the previous ESC question only. Yes. Two coils connected in parallel, L1 equal to 8 Henry, L2 equal to 2 Henry. If coupling coefficient K equal to 0.5, then what is the value of maximum possible inductance? Two coils are connected in parallel. What is L1 equal to 8 Henry? What is L2 equal to 2 Henry? If coupling coefficient K equal to 0.5, you want to find the maximum possible inductance. Connected in parallel for maximum possible inductance. Aiding is preferable or opposing is preferable? To get the maximum possible inductance, then which is preferable, students? Aiding or opposing? For maximum possible inductance, parallel, this is the aiding connection. To get the maximum possible, aiding is preferable. Why? To get the maximum possible inductance. But M is not given. To calculate the M, what it is given? K is given. What is the formula for M equal to? K into square root of L1 into L2. M is how that you want to calculate. K is 0.5. L1 is how much, students? 8. L2 is 2. Then how much M we can getting? How much you got? This is the 2 Henry. M equal to Henry. Then in parallel opposing, sorry, in parallel aiding connection. Why you prefer this one, sir? To get the maximum inductance in parallel. L1 L2 minus M square by L1 plus L2 minus 2M. In aiding connection here we can get minus L1 L2. L1 is how much? 8. L2 is 2. M is 2. 2 square by 8 plus 2 minus 2 into 2. That is 16 minus 4 by 10 minus 4. That is 12 by 6. This is how much we are getting? 2 Henry. Which option is correct? Option D is correct. This is equal to 2 Henry we are getting. Yes. In the network below, for what value of turns ratio? The 100 ohm load almost maximum power. That is for maximum power transfer. What is the value of turns ratio? What is the value of turns ratio that you want to find? In the network below, for what value of turns ratio? The 100 ohm load almost maximum power. Yes. It's very simple. For maximum power transfer, first what I can do, students, let convert this current source into, apply the source transformation here. If you apply the source transformation, what you can get? For source transformation, this is the is into 1. You convert into voltage source. This is is into 1. 1 ohm resistor is in series. Then this already it is a 3 ohm resistor. Then you can transfer this resistance into primary. If you transfer from this resistance into primary means what is the turns ratio here? Sorry, transformation ratio n by 1. That is n by 1. Then you can transform into this side 100 by n square. This is 100 by n square. Okay, 100 by n square. Then what is the RTH? This is the RTH. RTH equal to 4 ohms. Then we know that for maximum power transfer, for maximum power transfer, what is the condition? That is RL equal to RTH. That is 100 by n square equal to, this is 4. Then what is n square equal to? 25. Yes. Then what is n equal to? 5. Its value of n equal to 5. Option C is correct. What value of turns ratio? I think it is not a turns ratio. It is a transformation ratio, because once you know the n is 5, then turns ratio is 1:5. Transformation ratio is 5:1. Is it correct? Yes. That's why what value of transformation ratio? Transformation ratio. I got the n equal to 5. Then what the transformation ratio? Transformation ratio equal to, that is n by 1. That is 5 by 1. That equal to 5. That's why answer is C. Option C is correct. Like this you please correct this one. What value of transformation ratio? Turns ratio means 1 by 5. This is question number. This is 13, and this is the 14. Following data refers to two coupled coils, 1 and 2 as shown in figure. Pi 11 equal 0.5 milliweber, pi 12 equal 0.3 milliweber, N1 equal 100 tons centimeter. Then what is the value of L2? Then you want to find what is the L2 value. Yes, friends. Pi 11 is the leakage flux. Pi 12 is the mutual flux. This terminology already given. Then what the total flux pi 1 equal? These formulas I given already in the previous sessions. Pi 1 plus pi 1 equal to pi 11 plus pi 12. Pi 11 plus pi 1. Pi 12 is the mutual flux. Pi 11 is the leakage flux. 0.5 plus 0.3, that equal to 0.8 milliweber. Once you know the pi 1, you can find the L1. N1 pi 1 by I1. N1 pi 1 by I1. Yes, friends, this is N1 is how much? That is given that 100. This is 0.8. I1 is 1 ampere. Okay, this is how much? 0. But 8 milliweber. Na? This is 8 milliweber. Milli in the sense 10 to the power of minus 3. 0.08 Henry. Then what is the K value? K, how to find the K equal to? I already given this for all these formulas I already given in the previous sessions. Please go through that. That I defined mutual flux. Pi 12 equal to K into pi 1. Then from this, what is the K? K equal to pi 12 by pi 1. What is the pi 12? That is a mutual flux 0.3. What is the pi 1? 0.8. This is how much? 0.377. 0.377 you can get. Then from this we can define the M. How to define the M? N2 into pi 12 by I1. N2 is how much? 500. Pi 12 is how much? 0.377. It is a milli. It is also in terms of which one, students? Pi 12 by pi 1. Pi 1 is also milliwebers. This then 0.377. K value is 0.377. N2. Pi 12 is given. Yeah, pi 12 is 0.3 milliweber. 0.3 into 10 to the power of minus 3. I1 is 1 ampere. This is how much you can get. M. You please simplify this one. I think you can get 0.15 Henry. Is it correct? 0.5 into 0.3, 0.15 Henry. Once I know the M value, I know, K value, I know, L1 value, I know. Then I want to find the L2. Then I want to find the L2. Then what the formula for M equal to? M equal to K into square root of L1 into L2. Then solve for L2. We can get L2 equal to 2 Henry, students. By saying, you know L1 value that you substitute. M also you know. K also I calculated. All these we can substitute. We can get L2 equal to 2 Henry. Option C is correct. Clear? Like this you can proceed. See the one more question. Yes. For the given circuit, which of the following sets of equation is correct? For this circuit, which of the following sets of equation is correct? It's aiding or opposing, students? It is opposing. Opposing means compulsory M must be negative. M must be negative. Opposing means M must be negative. Then V1 of t equal to L1 into di1 by dt minus M into di2 by dt. V2 of t equal to L2 into di2 by dt minus M into di1 by dt. Then which option is correct? Option B is correct. Is okay? You please check this one. What is, I'm writing here aiding or opposing. It is opposing connection. It is a opposing. Then because for this coil dot is starting, for this coil dot is at ending. That's why you can write L1 into di1 by dt minus M into di2 by dt. V2 of t equal to L2 into di2 by dt, because this self inductance is because of this current. But the mutual inductance For mutual inductance of this coil is because of this current, di1 by dt. For this coil, with respect to this one, the mutual inductance is because of this current. That's why option B is correct. Okay, like this we can proceed the different models of the problems. Yes, any doubts? All these are the problems with respect to, yes friends, coupled circuits. See, one problem here I'm solving, one more problem. 14. Write. So question number is, that is 14, this is 15, and this is the 16. Question number 16. Write complete inductance matrix. Write complete inductance matrix inductance matrix matrix system of mutually coupled coils. System of mutually coupled coils. Mutually coupled coils as shown in figure. As shown in figure. Yes. Okay, this is the given system of mutually coupled coils. Yes. This is 5 Henry. This is 4 Henry. 5 Henry, 4 Henry. And this is 6 Henry. 6 Henry. This is V1 and this is I1. This is V2 and this is I2. And this is V3 and this is I3. Polarities are given plus minus. The I2 is given here. Plus minus. Here also I3 is given. Okay, this is I2. Here I3 is given. Plus minus. So then you write the system of matrix. That is a coupled coils matrix. How to write V1, students? What is V1? You tell me. 5 into di1 by dt. 5 into di1 by dt. But the dots also given. You please, this is given in the problem. This is the dot. And this is the dot. And for this coil, this is the dot. Dots are issued like this. Now tell me what is V1? 5 into di1 by dt. And coils are coupled. These three mutual inductance is given. Is 3 Henry. And this mutual inductance is given 4 Henry. Between these two, it is given that 4 Henry. That is given 2 Henry. And this is given 1 Henry. Between these two, it is given that 1 Henry. Now tell me, this is 5 into di1 by dt. I'm writing v1. 5 into di1 by dt. Now see, here starting terminal is dot, here also, but the dot is given here. For this coil, a dot current is entering. For this coil, at the dot current is leaving. That means these two are mutually opposing. Mutually opposing. Opposing means what you can write? Minus 3 into di2 by dt. Next. Here also connection is there. At this dot current is entering, but at this dot current is entering. I am comparing these two coils. At this dot current is entering, at this dot current is entering. Plus 1. What is the mutual inductance? 1. 1 into di3 by dt. One equation is completed. What is V2? Yes, friends, what about V2? V2 equal to self-inductance is as it is 4 into di2 by dt. 4 into di2 by dt. But these two are opposing. Minus 3 into di1 by dt. Then what about this coil and this coil? At this dot current is leaving, but here current is entering. At this dot current is entering. That's why these two are opposing. That's why minus 2 into di3 by dt. Then how to write V3? V3 equal to, what is the self-inductance? 6 into di3 by dt. And these two coils are opposing. That's why we can write 1 into, these two is aiding or opposing? Aiding. Plus 1 into di1 by dt. And what about these two coils? Opposing. Minus 2 into di2 by dt. Is it correct, friends? Then you can write this is V1, V2, V3. I'm writing in terms of matrix. Writing in terms of matrix. Then 5, minus 3, 1, 4, 4, sorry. In terms of I1, I2, I3. No? I want to write in terms of I1, I2, I3. I'm writing in terms of matrix. I1, I2, I3. First I1. 5, I2, minus 3, I3, 1, I1, minus 3, I2, 4, I3, minus 2. Next, I1, 1, I2, minus 2, I3, 6, into, you can write in terms, first I1, next I2, I3. This is I1, this is I2, this is I3. Okay, this is the system of matrix, mutually coupled matrix. This 5, 4, 6 indicates which one? This diagonal matrix indicate the self-inductance. The diagonal matrix indicate the self-inductance. Clear, friends? Like this, we can first check the is aiding or opposing. Aiding or opposing. Okay, like this, these are the different models of questions with respect to coupled circuits. With this, coupled circuits concepts is completed. And tomorrow I'm starting the new concept according to your syllabus, two-port networks. Okay, thank you, friends. I'm ending the session. Thank you. Is it okay? Yes. Tomorrow, same timing at 5 o'clock, I'm starting the new topic, that is the two-port networks. Yes, thank you. If you have any doubts, you can share. I already given Telegram channel. In that Telegram channel, you can share your doubts. Thank you.